everyone. We're back. Welcome back to track 1 of XConf Europe this year. My name is Raquel, and I'm going to be helping Chris out with facilitating this track throughout the day. I am wearing a red t-shirt and I have my hair down, which might make a lot of people that know me not recognize me because that's usually not how I usually am seen. I wanted to say that I am a self-proclaimed perfectionist, so I'm very eager to hear from our next speakers, Emily Karungi and Mihaela Pascuta, on how perfect is the enemy of good, and how the way of viewing technical debt is integral to taming that perfectionism that sometimes are innate into our lives. They propose an evolutionary design approach that would help with the analysis paralysis that comes with those for people like us perfectionists. So Emily, Mihaela, the metaphorical floor is yours.
Thank you. Okay, so let me share my screen. Okay, can you hear me well? Can you see the screen? Perfect, right? As developers, we want to write good quality code that delivers value to our customers, but often we are forced to take certain decisions that may not be the best for the future, hence creating tech debt. Hi, I'm Mihaela, and I'm a tech debt producer.
And hi, I'm Emily, and I produce more tech debt every day. So perfect, the enemy of good, might sound confusing, but our promise in this talk is to give you good arguments to make you believe in this statement.
So we don't want to argue that the perfect product or the perfect software cannot be built. It can. Humans can build the perfect product, but do we have the time for it? Is it a price that we can pay? The good beauty that comes for free, it doesn't exist. And as you said, Raquel, in software development, we have a really hard time doing the trade-off. So in this talk, we want to see how we can tame perfectionism with evolutionary design. So our agenda is we want to go over the issues that we managed to solve while moving from delivering the perfect software to deliver the good product. What approach did we take? Why to go evolutionary? The effect of perfectionism, and some tools to make the evolutionary design work. And yes, we are going to talk a lot about tech debt. Okay, so why to go evolutionary? Everyone wants the perfect software, but how realistic is it? And when we think about building the perfect software, what are we doing? Where do we start? So we gather the requirements and we create a plan. We plan for perfect. And most probably we will create an architecture. And we may get something like this, a big architecture diagram. Or if we move a bit from software and we think about the product, we may get something like this. So in software design, so most of the software design, it's inspired from the civil engineering, but we want to change a bit the analogy, and in this presentation, we're going to use a tailless craft for making our case. So you see here a plan of a dress, and you can see that you have the dimensions, a pattern, all the signs on where to do each cut. And to relate the dress plan in software, Martin Fowler calls it plan-driven thinking. And yes, we can develop like this and we can implement the perfect, and we can take in consideration all the requirements, security, performance, everything. But the plan, it is dependent on stable requirements. The measurement, the dimensions are not changing. And because of that, we can follow everything step by step for the plan. And what we really like about this example, compared with the analogies for building skyscrapers or building in general, is that creating a dress comes also with a change in the requirements, as we have in software. So we may have to add more pockets to the dress or make it smaller. And we all know that we wouldn't expect, even if we have this plan, to end up with something like this. Fancy, right? So we cannot follow the plan all the time. And there are some other disadvantages for upfront design. So the first one, we discuss about the requirement stability. And yes, trying to predict the future leads to over-engineering. But there are some other points. It is impossible to see all the issues that might arise while developing. And then it's really easy to get into the analysis paralysis effect. Also, we will have to do estimation based on the plan. And let's not forget that time passes and technology evolves, and we have to evolve too. So we encourage to stop planning, especially stop planning for the perfect and start developing the good. Emily will walk us through some alternatives.
Right. So the design spectrum is wide. We have big design upfront, we have cowboy hacking, we have emergent design, agile, etc. But today we want to bring your focus to something called evolutionary architecture. So by definition, evolutionary architecture is an architecture that supports guided incremental change as a first principle across multiple dimensions. What do we mean by this? So we make a plan, yes, but we expect this plan to change, both on the tech and the business side. And we prepare for that change. And after preparing, we guide the change as well. So we guide the change using something called fitness functions. What fitness functions are, they describe how well a system meets specified architecture goals in an automated way. So in other words, fitness functions are telling us if our system is moving in the good or it's moving in the bad direction. We want to evolve, but then also we don't want to evolve in a way that could harm our architecture concerns. A good example of implementation of fitness functions could be, for example, you do security analysis or you measure your test coverage. Evolutionary architecture also focuses on architecture coupling, meaning how different pieces of your architecture connect and rely on one another. So if you want to dig deeper into the concepts of evolutionary architecture, we recommend you to read this book called Building Evolutionary Architectures, which was written by Neil Ford, Rebecca Parsons, and Parker. It's a really good book. And speaking of evolution, nature does it incrementally as well. So in this picture, we have the evolution of humans. And going back to software, in this picture, we have an example of the evolution of a database. So it's starting off with one table, and then it keeps evolving to multiple tables, and it keeps evolving and evolving. So going back to our tailor craft analogy, let's say that a tailor is tasked to create 10 dresses. Each dress has a lace, each dress has a fishtail, each dress is long sleeved, but the dresses have different colors and different sizes. So in an evolutionary way, a tailor decides to create one dress first. So after they create the dress, then they call in their customer to gather feedback. And what they decide to do is, so they create the skirt first, and then after they add the mermaid tail, after they add the top, and finally they add the sleeves. And they end up with something that looks like this. It looks good, no? Let's see. After the dress is made, at this point they call in the customer to try on the dress and to receive some feedback from them. And when they do at this point, they actually realize that they missed out on a small detail, which is the darts. Now, if you're used to making dresses, you know that adding the darts once a complete dress is made is quite tricky. So that would mean that the tailor would need to tear down this one dress and rebuild it from scratch. So in this case, what do you think went wrong? When do you think the tailor should have called in the customer to get some feedback from them? Or another thing is they realized that the skirt of the dress is a bit tight as well. So there are some options. The tailor could tear down the dress and start from scratch, but maybe they can do a trade-off and decide to keep this dress the way it is, and then add the darts for all the other 9 dresses. So what are we trying to say? In software development, it works the same way. When we build in an evolutionary way, or when we choose to go evolutionary, we need to bear in mind some considerations. And let's see these. So here are some of our considerations while developing in an evolutionary way. The first is finding the last responsible moment, and then breaking down requirements into small ones that can be developed iteratively. And another consideration is essential, accidental complexity, and tech debt. All these are a developer responsibility, but well, some could be shared with the product as well. But tackling tech debt is also a product responsibility. Doing some trade-offs and prioritization is another consideration that we need to have in mind. And of course, all these are going to tie into team dynamics. So we need to pay close attention to team dynamics when we choose to go evolutionary. I'm going to hand it over to Mihaela to dig deeper into these concepts.
Yes, so the first one is the last responsible moment. The last responsible moment is a lean principle, and it's about not making a premature decision, but delaying the commitment until the cost of not making that decision becomes greater than the cost of making it. So we should all time develop with the perfect in mind. But we shouldn't do anything until the last responsible moment. So by now, probably everyone is familiar with trading cryptocurrencies. And we want to use this graph that shows the Bitcoin selling prices over 5 or 6 years. And we want to ask you, when is the right time to trade? You may want to buy low, you want to buy low and sell high, but it's very hard to find out which is the last moment to take the decision. And what we want to emphasize here is that we should make sure that we just do the decision when it's not irresponsible to make that decision. And maybe here, I don't know, like when you lost half of your portfolio, maybe you should take a decision. Or in the case of a software project, we may define the last responsible moment when defining the MVP of a project, or defining the sprint scope, or when we start a feature or a user story, or when we actually start the development of the feature. Of course, when you have a bug in production, or when the customer starts complaining about your features. So the last responsible moment can be on any stage of development. But an example when it is irresponsible not to react immediately, it will be when you have an incident in production. So if you have an incident in production, you're probably past of the last responsible moment and you have to act immediately. The next considerations are about the accidental and essential complexity. So both accidental and essential complexity contribute to the cost of your feature, but let's see how. So essential complexity, it refers to how hard is something in regards of your level of experience or expertise. It is the property of the problem that you are trying to solve. For our desk, it could be the darts. And in a software project, it will be that algorithm that it's really hard to understand, but it's hard because the domain business logic is hard to understand. It's not hard to understand just because the code is messy. So, of course, not all complexity is essential. We do bring our own level of complexity while we write code and we choose approaches. So to describe accidental complexity, think about those features or code that are not used anymore, but maintained in your system just because you don't know how or why they are working. And it's just code that it has to be maintained. So basically anything in your code that doesn't or that tries to solve a problem that you don't have, it's accidental complexity. And now it comes tech debt. So introducing tech debt increases accidental complexity. And some side effect is that you're gonna go slower and slower by developing. So let's see what is tech debt. A good way to think about the tech debt is to try and relate it to a bank loan. Yeah, hopefully not a loan to buy a dress. So when we get a loan, we open ourselves to be in debt. And being in debt is not a situation that anyone desires. However, some level of debt, it will allow you to get some things moving forward. So when we do apply for a loan, we consider a couple of things: the interest rate and the interest that you'll have to pay, and the implication for your future. If you buy a house, it will be okay. You'll have to spend a big amount of time to repaying it, and it will be a big implication for your future. So in software, the tech debt, it works exactly the same way. So what we are trying to say that accepting some level of technical debt creates room for fast feedback and fast monetization. So imagine you are developing one feature, maybe for different customer segments. So you can see here I don't know, a pink brand A, dark pinker brand B, and so on. So maybe your feature has the same look and feel, maybe the same functionality, they're just a bit different. So if we choose to do it maybe with a hard-coded conditions, like to implement the features doing hard-coded conditions, or doing fast delivery, whatever that means, we will be able to deliver for our base customer. And yes, here is where we are creating tech debt. Just because we are not generalizing and not delivering for everyone. And as I said, maybe you do have to hard code some things, but this tech debt, it will be, and it will allow us to get feedback immediately from the customer and learn about the shortcomings of the feature. So, of course, if you implement like this for one customer, as we saw in the earlier example with one dress, then you'll be able to move to the next one, do it better, and iterate into generalizing your solution. So, you may still say why we are not doing it perfect from the beginning. We know all the requirements, but what do we do? So there are some tech debt misconceptions, and Emily will show us and walk us through some.
Right. So why we're not doing it perfect from the beginning? So when we talk about tech debt, we are not meaning messy code. So like we see in this software design and architecture stack, we have different layers. We have clean code, programming paradigms, object-oriented programming, etc. So accepting some level of debt doesn't mean that we should be compromising on essential development standards. We should still be able to write clean code. We should develop code that is well tested, code that is easy to read, decoupled, solid, and easy to evolve. So while we introduce debt, it's important to reflect if the type of debt that we are, of technical debt that we are introducing is good, or if it's just messy code. Messy code is a problem, and we should not be in this state while we introduce debt, because this will compromise on quality, and as a result, it could cost the business a lot of money. So then you may ask, how do we know if the kind of debt that we're introducing is good? So while we develop, we can think of Ken Beck's rules of simple design. The first is, does my code pass the tests? Does it reveal its intention? Is it dry, or we don't have duplication? And fewest elements first. So fewest elements first means that remove anything that doesn't meet the first three rules. So you can try to reflect on this while you're introducing data into your system. And if your data is not meeting some of these qualities, then it probably could be that you're not introducing technical debt, but what you're introducing is actually a mess in your code. So we mentioned that it's relevant to tackle debt. Let's see why it's relevant to tackle debt. Just like the second law of thermodynamics states, the entropy of any isolated system always increases. And reflecting back on nature, just like the glaciers are melting away, because we humans are unable to manage climate change, as we develop, the entropy of our design systems will always increase. Therefore, it's relevant for us to manage entropy and have some strategies in place to manage accidental complexity. Because if we don't do this, then the systems that we are building or systems that we are designing will die or will collapse. Let's talk about tech debt in teams. How do we tackle debt in a team, or how do we get a team to start thinking about tech debt? So these are some of the ways we have done it on our team. The first one is having fixed placeholders in every iteration. And another thing we do is we have streamlined conversations, and we review prioritized tech debt tickets with product people as well. It's important also to have some kind of visibility or some kind of metrics in place, which will reveal to us how much tech debt do we have, or how much tech debt do we have pending to be covered. Of course, all these are going to vary from team to team. We are saying that these three are the standard, but what is relevant is to have some strategy in place, or to think about how we are going to manage tech debt on our team. Here's an example of a tool that we use in Thoughtworks or on our team. It's the tech debt wall. So what we would do is that we map the tickets that we have, the tech debt tickets that we have, against these two quadrants. So we try to think which things are causing us a lot of pain or not causing us a lot of pain, and what is the effort of implementing these features. So usually we would consider the quadrant on the bottom right first. These are also known as the low-hanging fruits, and these are the things that they are causing a lot of pain and are low effort to implement. We would pick this out first and try to implement them. So this is a tool that you can use to prioritize your tech debt, but there are several other tools that you can use as well. So we talked about what perfectionism is. We have seen how it can be avoided. Let's look at its effects if we don't tame it. So the first is on team, silo team structure. Organization of cross-functional teams always reflects on the architecture of applications, where we have this split between UX, backend, QA, frontend. Sometimes it does shape how microservices are created or distributed. Actually, organizations that are looking to achieve very high perfectionism sometimes go an extra mile to hire specialists like lead, senior front-end developer. But this also comes with an extra cost. It comes with an extra cost both in creating knowledge silos and creating a lot of dependencies between teams. Perfectionism shapes team dynamics. So in order to get the perfect product created, we might be tempted to put more people on the team with the hope that we will get it all perfect from the beginning. But like number states that teams cannot grow forever. So having many people on a team will not reduce cognitive load. Actually, it might make the problem even worse, because in this case, we will need to be able to manage the communication among the teams or the team members. And we also need to manage some sort of synchronization and knowledge sharing. And in case of a software project, we might be tempted to put more developers on a team with the hope that everything will be built all perfect from the beginning. But this won't be the case. Like we said, we need to manage synchronization. We need to manage team members. So what we're trying to say is that managing communication becomes very complex as teams grow in size. So think about your team size, and we recommend you to keep teams as small as possible. To keep track of performance of a team, something we use on our team is called the 4 key metrics, and that is deployment frequency, mean time to recover, change failure rate, and lead time for changes. So we've seen that perfectionism has a direct impact on the metrics of the team. So for example, high perfectionism expectations will have a direct impact on the lead time of the team. And this is usually because we have stories in work in progress for a very long period of time, or teams not being able to split the stories into small ones that they can develop iteratively. And another cause of the lead time being high could be that if you have tickets in pull request review for a very long period of time. And speaking about pull requests, we've seen that pull requests are among the biggest blockers for going fast to production. In this picture, we tried to mimic what a pull request review cycle would look like, where a developer creates a pull request and then they are stopped because they need to make some changes, then they fix the changes, and then they need to make more fixes until they get the green lights to actually merge the pull request. So what do organizations want to achieve with pull requests? So usually it's because we don't want to break the features that we already have live or we have in production. And that forces us to treat the main branch as a delicate vessel that we shouldn't break. Okay, if we want to achieve code perfection or do it all perfect from the beginning, what if we replaced the PR police that we have in this picture with pair programming? What would happen? So what is pair programming? So pair programming is when you have two people working on the same task. So pairing provides more space to coach and to pass feedback carefully and fast. It is a good replacement for pull request, because what it does is that it enhances you to do peer review at a very early stage. So even before you submit your PR, if you have two people working on the same task, you have two pairs of eyes that are working on the same task. It also removes knowledge silos and also encourages collective code ownership. So pairing is a good way to manage perfectionism, or if you want to have peer review done, pairing is a good replacement for pull requests. High perfectionism has an impact on the team morale as well, because not being able to deploy features to production as soon as possible, it's not a good state to be in. So it's important to note that an organization's culture does shape team dynamics. So we should not try to solve the organization culture through code. No, we should not. So we've seen what perfectionism is, and we've seen why we need to avoid it. So let's see some of the tools we can use to tame it. And I'm going to hand it over to Mihaela to tell us.
Yes, thank you. Thank you, Emily. So building in an evolutionary way is done through incremental change. And what better way to do incremental change than using TDD? TDD always reveals us the smallest thing that we can develop. We write a test, we see it fail, we make it pass, and we make it pass with the smallest code possible. And there is where we reach the good. Then, of course, we can refactor to get closer to the perfect, but just closer to the perfect. And the second keyword, it's refactoring. So we do small steps that allow us to make a big change. With every change, with every step, we can put everything directly to production, and we improve the code, but in return, we also improve the product. So you really shouldn't wait for having everything done. You should do small but continuous improvement. And yes, as you may have guessed from this picture, having a delivery person, continuous improvement may be hard to achieve without continuous delivery. It can be a new feature, a bug fix, or what we just saw, refactoring. With CI/CD, you can get your good software into the hands of users easy and very fast. And if by now you still want to wait a bit to get the product closer to perfect, then you can use feature flags or feature toggles. With them, you are allowed to do many incremental versions, and everything can be delivered without the cost of branching and merging. So you can safely release your software in bits and enable everything when the product is good enough. And the emphasis here on good enough, including for the product. Okay, so we recognize that feature flags may be seen as technical debt, but it is debt that is manageable. And it could get really easy clean out of your system. And we encourage to prepare your architecture to do it and to support the auto removal for you. So if you still have a hard time deciding on what you need to implement or how you have to do it, we recommend you to code as you'll have to delete everything tomorrow. So if you code with this in mind, you will isolate your changes and you'll get mentally prepared to let your code go. Emphasis is that you need, and with this practice, you could decouple your code and you'd have a good enough software. So these are our tools. I'm sure everyone is familiar by now with all these concepts. If you didn't try it, you should. And with this, we are able to move further to develop while trying to stay on track to deliver perfect. And the message that we want to leave you with, Emily?
Yes. So the message that we want to leave you with is that when we term perfectionism, we are promoting continuous improvement. So we should take small steps towards our high quality goal. And to prove the point of our talk, if we had waited to give this presentation in a perfect way or to have it perfect before we give it, maybe we would have given it in 5 years, but then who knows, maybe in 5 years, some of this content wouldn't make sense. So we decided to give it today because we know that perfect is the enemy of good. So thank you.
Thank you, and thanks a lot to our team for reviewing the content and also helping out with this content.
Thank you, Mihaela and Emily. That was very, very great. We have a couple of minutes before we head off to another break in the next talk. And just as an FYI, for more questions, we won't be able to cover all of them, but please reach out on Slack. I really liked the talk. I really liked giving like examples on real life, the dress, the crypto market, the talk itself, right? And to me, it's all about, you want to optimize your return of investment, right? You want to get to market on optimize and talk to your users. I really liked when y'all were talking about, it's not an excuse, right? Tech debt is not an excuse. It's not your excuse to write messy code. There's a balance there that you need to find, and you shouldn't use tech to solve your company's problem. Talking a little bit on you all mentioned that tackling tech debt is a product responsibility as well, right? And as someone that has had to have the conversation of advocating for prioritizing tech debt, do you have any tips for having those conversations and trying to get that so that it's not the developers are being precious with their code and those types of conversations?
Right.
Yes. Okay.
So
yes.
it,
this happens, right, when you do pairing.
Yeah.
Okay, so yes, some of the practices that we are using, it's while discussing the prioritization of the features, we do the trades-off, right? So it's something, we are using something called like trades-off sliders, in which you prioritize the features from, okay, it's a must, or it's something that is not really important at this moment. So with prioritizing what is important from the product perspective, you can also negotiate what development for can be done and at which point you get to production and with what kind of debt, right? So if you negotiate that for delivering a feature, you will need 2 weeks, then you may want to deliver something already after 1 day, right? So with just having the first delivery with something small, you will be able to like adapt your estimations and really set that, okay, we did deliver this, but it's not ready. We still need the rest of the time to fix everything else, but we will have more information about what needs to be fixed. I don't know, Emily, you wanted to, maybe you want to add to this?
Yeah, just something small. So tech debt is part of our, should be part of our work as well. So one good trick is keep your technical debt in your backlog. So usually product is looking at our backlog and seeing what features we have developed and what features we have pending to be developed. So if you have your tech debt tickets in your backlog, it's also visible to the product people what things we need to tackle with tech debt. So we shouldn't have a separate way of tackling technical debt than it should be tackled like the features that we plan to develop as well. And like we said, we need to have those streamlined conversations, because product might always want to have new features built or new features developed and deployed to production, and ignore that we have this tech debt that we need to tackle. So that's why it's really relevant that we keep the tech debt tickets or the tech debt that we have very close to the new features that we want to develop. And once we have that close, when we do things like planning or backlog refinement, it's very easy for product people to see the features that for tech debt that need to be tackled as well.
Makes sense. So keep it visible and talk their language is a good tip to go forward. We have 2 minutes. I have a quick one that maybe y'all can help. Are there any times where it's okay to be perfectionists? To say yes to the little voice in our heads?
Yeah, that's a good one. So of course they would be, it depends on the requirements also for your projects. There are things that we might not want to compromise on. A good example is security. We want to build applications that are secure. So in that moment, we might want to be perfectionists, so to be perfect and make sure we don't mess up our applications. But then also, I would say that it's it's not possible to achieve 100% security, for example, because it also has different levels. You might have security at the authentication level, logging, encryption. It really you need to weigh in on what are the things that are a must to have, what are the things that we cannot go without. So maybe in that moment, it does make sense to have some level of perfectionism, but then I would say that it's also hard to achieve 100% perfectionism. I don't know if you have anything else, Mihaela.
No, you explained it very well. Thank you.
Yeah, one thing that comes to mind is GDPR as well, right? There are laws and there are things that you need to achieve on, and sometimes those are the baselines that we're at. We are at time, so I will get some of the questions that are on the Q&A, forward them to Slack, where both Emily and Mihaela will be available for a little bit. And I will see y'all here back at track 1 at 1:25 for thinking in types.